Welcome to the For Science Salah Lotfy channel. Today we have a fascinating topic to introduce to you. We're kicking off a comprehensive series on a groundbreaking research project titled The Use of Ionizing Irradiation to Prepare Polyethylene Wax and Agro-Waste Composite. This innovative study explores the potential of combining polyethylene wax with agricultural waste materials, aiming to create a sustainable and efficient composite. This research was conducted by a distinguished team of experts, including Professor Dr. Hussein Elnahas, Professor Dr. Mohamed Elhady, Professor Dr. Christopher Liauw, and Professor Dr. Shabaan Kamel. Their collaborative efforts have paved the way for new advancements in materials science, showcasing the importance of interdisciplinary research in solving complex problems. This research focuses on a novel approach to recycling agricultural and plastic waste, such as polyethylene. By converting polyethylene into polyethylene wax through ionizing irradiation, the study aims to produce plastic wood with remarkable properties. The goal is to utilize this transformed polyethylene wax and agro-waste to create a plastic wood that possesses all the qualities of regular wood. This includes paintability, sawability, and nailability, making it versatile for various applications. By combining these materials, we aim to produce a sustainable and eco-friendly alternative to traditional wood. This innovative plastic wood can be used in construction, furniture making, and even in outdoor settings. It offers durability and resistance to weather conditions, ensuring a longer lifespan. Our research focuses on optimizing the blend to achieve the best possible performance, ensuring it meets industry standards and consumer expectations. Additionally, this innovative wood demonstrates exceptional water resistance and includes unique types such as rubber wood and fire-resistant wood. This opens up new possibilities for sustainable and durable materials in construction and manufacturing. In this introductory episode, we'll provide an overview of this remarkable research and its potential impact. We'll explore the objectives, the process of converting waste materials, and the extraordinary properties of the resulting plastic wood. Stay tuned for our detailed 40-minute video, where we will explore every aspect of this groundbreaking research. We'll dive deep into the methodology, results, and implications of this study, providing you with a comprehensive understanding of the scientific process. Don't forget to like, share, and subscribe to the For Science Salah Lotfy channel. Your support helps us bring more insightful scientific content to you. By subscribing, you'll stay updated with our latest videos and never miss out on important scientific discoveries. Let's embark on this journey together, fostering a community of curious minds and passionate learners. Together, we can discover innovative solutions for a sustainable future, making a positive impact on our world. Join us in this exciting adventure.
Hey there, science fans. It's your favorite science guy, Bill Nye, here to talk about a pressing issue that's affecting all of us. Today, we're tackling a big one: trash. Yes, you heard that right. Trash is becoming an enormous problem, and it's something we need to address urgently. Our planet is drowning in it, especially plastic. Everywhere you look, there's plastic waste. On our beaches, in our parks, and even in remote areas where you wouldn't expect to find it. It's clogging our oceans, filling up landfills, and harming wildlife. Sea turtles, birds, and other animals are getting tangled in it or mistaking it for food, which can be fatal. And guess what? The problem is only getting bigger. Every year we produce more and more plastic, and a significant portion of it ends up as waste. We produce mountains of plastic every year, and much of it isn't recycled. In fact, only a small percentage of plastic waste is actually recycled. The rest ends up in landfills or the environment. But wait, there's more. We also generate tons of agricultural waste, like leftover crops and husks. This waste often gets burned or left to rot, contributing to pollution and greenhouse gas emissions. What if we could take all this waste and turn it into something useful? Imagine a world where waste isn't just waste, but a valuable resource, something that could even help the environment. By converting waste into eco-friendly products, we could reduce pollution and conserve natural resources. Well, get ready to be amazed, because with a little science, we can. Scientists and innovators around the world are developing new technologies to recycle and repurpose waste in ways we never thought possible. From turning plastic into fuel to creating biodegradable materials, the possibilities are endless. So stay tuned as we explore these groundbreaking solutions and learn how we can all contribute to a cleaner, greener planet. Now let's talk about a game-changing technology: ionizing irradiation. Sounds complicated? Don't worry, it's simpler than you think. Basically, it's like giving waste materials a powerful burst of energy. This energy breaks down the molecules in the waste, making them easier to reshape and mold into something new. Think of it like softening up dough before you bake it. Ionizing irradiation helps us soften the waste so we can transform it into valuable materials. Pretty neat, right? So, how do we turn plastic and agricultural waste into something useful? The first step is turning polyethylene, a common plastic, into polyethylene wax. We use our new friend, ionizing irradiation, to do the trick. The irradiation process breaks down the polyethylene structure, turning it into a waxy substance. This polyethylene wax is a valuable resource in itself, used in things like candles, coatings, and polishes. It's a win-win. We're reducing plastic waste and creating a useful product. But wait, there's more. This polyethylene wax is also the key ingredient in making something even more impressive: plastic wood. Now, for the main event, plastic wood, by combining polyethylene wax with agricultural waste like rice husks or sawdust, we can create a durable and versatile material. It's like magic, but it's science. This plastic wood has some amazing properties. It's water-resistant, rot-resistant, and incredibly strong. Plus, it's easy to work with, just like regular wood. We can saw it, nail it, and shape it into all sorts of things. Think park benches, fences, decking. The possibilities are endless. And the best part, we're using waste materials that would otherwise pollute our planet. But wait, there's another contender in the ring: rubber wood.
By tweaking the recipe and adding some rubber to the mix, we can create a material that's not only strong, but also flexible.
Rubber wood is perfect for applications where a bit of give is needed, like in flooring, car bumpers, or even playground equipment.
Imagine a playground where the swings and slides are made from recycled plastic and agricultural waste.
It's a fun, sustainable solution for a greener future. The environmental benefits of turning waste into plastic and rubber wood are huge.
First, we're tackling the massive problem of plastic and agricultural waste.
Less waste in landfills means less pollution and a healthier planet.
Second, we're reducing the need to cut down trees for wood.
Forests play a vital role in absorbing carbon dioxide and combating climate change, so protecting them is crucial.
And third, these new materials are durable and long-lasting, which means we'll need to replace them less often.
That translates to fewer resources used and less waste generated in the long run.
It's a win-win-win for the environment!
The future of waste management is all about seeing trash as a valuable resource. With innovative technologies like ionizing irradiation, we can transform what was once considered garbage into valuable materials. Imagine a world where landfills are a thing of the past, and waste is used to build homes, furniture, and even cars. It's not science fiction, it's the power of science and innovation at work. By embracing these new technologies and changing the way we think about waste, we can create a more sustainable and cleaner planet for generations to come. The science behind the transformation, a closer look. Now let's dive a little deeper into the science behind this amazing transformation. Remember how we talked about ionizing irradiation breaking down molecules? Well, here's how it works.
The irradiation process creates free radicals, which are highly reactive molecules. These free radicals then interact with the polyethylene and agricultural waste, causing them to bond together in a new way. This process, called cross-linking, is what gives plastic and rubber wood their strength, durability, and water resistance. It's like weaving together different strands of yarn to create a strong and resilient fabric.
Section 9. Applications beyond building, exploring new possibilities. The possibilities of using plastic and rubber wood are practically endless. While these materials are great for building and construction, we can use them for so much more. Imagine lightweight and durable furniture made from recycled materials, or even car parts that are both strong and recyclable. We can also use them to create durable and long-lasting packaging, reducing the need for single-use plastics. The key is to think creatively and explore new ways to incorporate these versatile materials into our everyday lives. Challenges and opportunities, scaling up for a greener tomorrow. While the technology to transform waste into valuable materials is promising, we still face significant challenges in scaling up production to meet the ever-growing global demands. The process of converting waste into useful products is not only innovative but also essential for a sustainable future. However, the journey from small-scale operations to large-scale production is fraught with obstacles that need to be addressed meticulously. One of the primary challenges is the high cost of ionizing irradiation equipment, which is crucial for the transformation process. This equipment is sophisticated and requires substantial investment, making it a barrier for many businesses, especially smaller enterprises, to adopt this technology.
However, there is hope on the horizon. As the technology continues to advance and more research is conducted, the cost of ionizing irradiation equipment is expected to decrease. This reduction in cost will make the technology more accessible, allowing a broader range of businesses and communities worldwide to benefit from it. The potential for widespread adoption is immense, and it could revolutionize the way we handle waste. Another significant challenge is ensuring a consistent and reliable supply of waste materials. The success of this technology depends heavily on the availability of raw waste materials, which requires efficient and effective waste collection and sorting systems. Establishing these systems can be a complex and resource-intensive undertaking. It involves not only the physical infrastructure but also the cooperation of communities, businesses, and governments to ensure that waste is collected and sorted properly. However, these challenges also present unique opportunities for innovation and collaboration. By bringing together diverse teams of engineers, scientists, and industry experts, we can develop new solutions and improve existing systems. By working together, we can overcome these obstacles and unlock the full potential of this game-changing technology. The future of waste transformation is bright, and with continued effort and collaboration, we can scale up for a greener tomorrow, creating a more sustainable and eco-friendly world for future generations.
Joining the solution, what you can do. You might be thinking, this is amazing, but what can I do to help? The good news is, there are many ways you can contribute to making a positive impact on our environment. Well, every little bit counts. Small actions, when multiplied by millions of people, can transform the world. First, reduce your plastic consumption. This can be as simple as using a reusable shopping bag instead of plastic ones, or carrying a reusable water bottle. Choose reusable alternatives whenever possible and recycle diligently. Make sure to sort your recyclables correctly to ensure they are processed efficiently. Second, support companies that are using recycled materials in their products. Look for labels that indicate products are made from recycled materials. By choosing sustainable options, you're sending a message that you care about the environment. Your purchasing decisions can drive demand for more eco-friendly products. And finally, spread the word. Educate others about the importance of recycling and reducing plastic waste. Share this information with your friends, family, and community. Host discussions at home or participate in local environmental events. The more people who know about this technology and its potential, the faster we can create a cleaner, greener future for everyone. Attend workshops and rallies to stay informed and motivated. Remember, together, we can make a difference. By working as a community, we can achieve significant environmental improvements and ensure a healthier planet for future generations.
Hello science enthusiasts, welcome to the For Science Salah Lotfy channel. Today, we're introducing a fascinating research paper titled, The Use of Ionizing Irradiation to Prepare Polyethylene Wax and Agro-Waste Composite. This groundbreaking study was published in the prestigious Journal of Nuclear Technology in Applied Science. It appeared in Volume 4, Issue 2, spanning pages 83 to 90. The publication date was in the year 2016. This journal is renowned for its rigorous peer review process and high-impact research articles. The study has since been cited by numerous subsequent research papers, highlighting its significance in the field. Researchers and academics worldwide have recognized the importance of this work, contributing to advancements in nuclear technology and applied science. The journal continues to be a leading source of innovative research. The research was a collaborative effort by an esteemed group of scientists. Let's introduce them. First, we have Professor Dr. Hussein Elnahas and Professor Dr. Mohamed Elhady from the Polymer Chemistry Department at the National Center for Radiation Research and Technology, Egyptian Atomic Energy Authority in Cairo, Egypt. These distinguished professors are renowned for their groundbreaking research in polymer chemistry, focusing on innovative applications and advancements in radiation technology. Their work has significantly contributed to the development of new materials and processes that have wide-ranging implications in various industries, including healthcare, environmental science, and manufacturing. By leveraging cutting-edge techniques and state-of-the-art equipment, they continue to push the boundaries of scientific knowledge, fostering collaboration and driving progress in their field. Next, we have Professor Dr. Christopher Liauw from the Center for Material Science Research, Faculty of Science and Engineering at Manchester Metropolitan University, UK. And finally, Professor Dr. Shabaan Kamel from the School of Science and the Environment, Chemistry and Environmental Division at Manchester Oxford Road, UK. Their research explores innovative methods to utilize ionizing irradiation for creating a composite of polyethylene wax and agricultural waste, offering new solutions for sustainable material production. The detailed methodologies and experiments provided in this study offer valuable insights into material science and environmental sustainability. Their collaborative efforts highlight the importance of international research partnerships. Stay tuned for more in-depth discussions on this groundbreaking research in our upcoming episodes. We will delve deeper into the methodologies, the challenges faced, and the potential implications of these findings. Our team of experts will provide detailed analyses and insights that you won't want to miss. Don't forget to like, share, and subscribe to the For Science Salah Lotfy channel to stay updated with the latest scientific discoveries and innovations. Your support helps us bring you more quality content. Until next time, keep exploring, stay curious, and never stop questioning the world around you. Thank you for watching, and we look forward to having you with us on this exciting journey of discovery. Hey there, science fans! Welcome back to another exciting journey into the world of science and innovation. Today, let's talk about something really important: protecting our planet. With climate change and environmental degradation on the rise, it's more crucial than ever to find sustainable solutions. One way we can do that is by finding new ways to use renewable resources. These resources are not only abundant, but also have the potential to revolutionize the way we live and work. Renewable resources are things that can be replenished naturally, like plants and sunlight. They offer a sustainable alternative to finite resources like fossil fuels, which are depleting rapidly. We can use these resources to create new materials like composites. Composites are incredibly versatile and can be tailored to meet specific needs, making them invaluable in various industries. Composites are just what they sound like: combinations of different materials. By combining materials with different properties, we can create something that is greater than the sum of its parts. Think of it like mixing flour, sugar, and eggs to make a cake. Each ingredient has its own unique properties, but when combined, they create something entirely new and delicious. Each ingredient has its own properties, but when combined, they create something new and delicious. Similarly, composite materials can be engineered to have specific characteristics, such as increased strength or reduced weight. Scientists and engineers are always looking for new ways to make composites stronger, lighter, and more sustainable. This ongoing research is crucial for developing materials that can meet the demands of modern technology and industry. That's where our exciting breakthrough comes in. After years of research and countless experiments, a team of brilliant minds has made a significant discovery. A team of brilliant minds have been hard at work developing a brand new composite material. This new material promises to be a game changer in the field of sustainable technology. And guess what? It's made from something you might not expect: agricultural waste. By repurposing waste materials, we can reduce environmental impact and create high-performance composites that are both eco-friendly and cost-effective. Agricultural waste, such as crop residues and plant fibers, is often discarded or burned, contributing to pollution. But now, this waste can be transformed into valuable resources. Through innovative processing techniques, scientists can extract useful components from agricultural waste and incorporate them into composite materials. This not only helps in waste management, but also provides a sustainable source of raw materials. The potential applications for these new composites are vast. From construction and automotive industries to consumer goods and electronics, the possibilities are endless. By embracing renewable composites, we can pave the way for a greener, more sustainable future. So next time you think about sustainability, remember the incredible potential of renewable composites. Together, we can make a difference and build a better world for future generations. Thanks for watching, and stay curious. Now you might be thinking, agricultural waste? How can that be useful? It seems like just another problem to deal with, right? Well, get ready to be amazed. Scientists have found a way to turn this waste into something incredibly valuable. This innovative process starts with something called polyethylene. It's a type of plastic that you encounter every day. You know those plastic bags we're always told to recycle? They're made from polyethylene. Many of them are made from a type of polyethylene called LDPE, which stands for low-density polyethylene. It's everywhere, from grocery bags to packaging materials. Scientists have figured out a way to transform LDPE into something called polyethylene wax. This wax has a multitude of applications. They do this using two cool processes, radiation and thermolysis. These processes are at the cutting edge of material science. Radiation is like giving the LDPE a little zap of energy, breaking down its molecular structure. And thermolysis is like using heat to break it down further, turning it into a useful wax. This polyethylene wax is the secret ingredient in our new composite material. It's not just any wax, it's a game changer. It acts like glue, holding everything together. Pretty neat, right? But wait, there's more. This composite material can be used in a variety of industries, from construction to automotive, making it incredibly versatile and valuable. Remember all that agricultural waste we talked about? Well, it turns out that stuff is a gold mine. We're talking about things like leftover stalks and stems from crops like wheat or rice. Instead of just throwing it away, we can use it to make our planet a little greener. Scientists take this agricultural waste and turn it into a fine powder. This powder is full of something called fiber, which is like the plant's skeleton. These fibers are incredibly strong and lightweight, making them perfect for creating durable and sustainable materials. By combining these fibers with the polyethylene wax, we can create a composite material that is both strong and environmentally friendly. Now let's head to the lab and see how this amazing composite is made. Picture this, a big mixing machine, kind of like the one you'd use to make bread. First, we add the agricultural waste powder to the mixer. Then in goes the polyethylene wax. We also add a few other ingredients, like special chemicals that help the mixture blend together nicely. Think of it like adding spices to your food. A little bit goes a long way. Once all the ingredients are in the mixer, we turn it on and let it do its thing. The mixer blends everything together until it forms a thick paste. This paste is the foundation of our super strong composite material. 3. Analyzing the composite's strength. In this section, we delve deep into the rigorous process of evaluating the robustness of our newly developed composite material. Now that we have our composite paste, it's time to put it to the test. This paste is the foundation of our material, and its properties will determine the overall strength and durability of the final product. We want to see just how strong and durable this new material really is. Our goal is to ensure that it can withstand various stresses and strains that it might encounter in real-world applications. To do this, we use something called a mold. The mold shapes the composite paste into a specific form, allowing us to create uniform samples for testing. A mold is like a cookie cutter for our composite material. It ensures that each sample is consistent in size and shape, which is crucial for accurate testing. We pour the paste into the mold and let it harden. This hardening process is essential as it transforms the paste into a solid, testable material. Once it's hard, we have a solid piece of our composite material that we can test. This piece will undergo a series of rigorous tests to evaluate its performance. We use special machines to stretch, bend, and squeeze the material. These machines simulate the forces the material will face in real-world conditions. This helps us see how much force it can withstand before it breaks. Understanding the breaking point is crucial for determining the material's suitability for various applications. We also test the material's resistance to heat, water, and even chemicals. These tests ensure that the composite can perform well under different environmental conditions, making it versatile and reliable for multiple uses. Section 6. Strong as steel, the surprising results. After putting our composite material through the wringer, the results are in. And guess what? This stuff is tough. The tests showed that the composite material is incredibly strong and durable. In fact, it's even stronger than some types of plastic. But that's not all. Remember how we talked about sustainability? Well, this composite material is biodegradable. That means it can break down naturally over time without harming the environment. How cool is that? We've created a material that is strong, durable, and good for the planet. Section 7. A world of possibilities. Applications of the composite. Now that we know how strong and sustainable this new composite material is, the possibilities are endless. Imagine a world where we could use this material to build lighter and more fuel-efficient cars. Or what about using it to create durable and sustainable furniture? This composite material could even be used in construction to build eco-friendly homes. From everyday objects to cutting-edge technology, the applications for this material are vast and exciting. Section 8. Saving the planet, one composite at a time. The development of this new composite material is a huge step forward in creating a more sustainable future. By using renewable resources like agricultural waste and polyethylene wax, we can reduce our reliance on fossil fuels and protect our planet. It's a win-win situation. We get strong and durable materials, and we reduce our impact on the environment. It's all about finding innovative solutions to the challenges we face and creating a better future for generations to come. Section 9. The future is green. The importance of continued research. This breakthrough in renewable composite technology is incredibly exciting, but our work isn't done yet. There's always more to learn and explore. Scientists and engineers are already hard at work, looking for new ways to improve this composite material and develop even more sustainable solutions. Imagine a future where we can create composites from other types of waste materials, further reducing our environmental impact. The possibilities are limitless. Section 10. Join the movement, support sustainable innovation. The development of this incredible composite material is a testament to the power of human ingenuity. It's a reminder that we have the power to create a better future for ourselves and for generations to come. But we can't do it alone. We need your help. Support companies that are committed to sustainability and invest in research and development of renewable technologies. Together, we can make a difference. Section 11, a final thought. Building a better tomorrow. As we've learned today, even something as simple as agricultural waste can be transformed into something extraordinary. By embracing innovation and sustainable practices, we can create a brighter future for our planet. So, let's all do our part to reduce, reuse, and recycle. Let's support sustainable technologies and work together to build a better tomorrow, one composite at a time. Stay curious, stay informed, and never stop exploring the wonders of science.
Have you ever wondered what happens to things we throw away? Every day, tons of waste end up in landfills, contributing to pollution and environmental degradation. Things like plastic bags or the stems and leaves from plants. These items, often considered useless, are discarded without a second thought. What if we told you these leftovers could be turned into something new and useful? Imagine transforming waste into valuable resources, reducing our environmental footprint. That's what we're doing in our science lab. Our team of dedicated researchers is working tirelessly to find innovative solutions to the waste problem. We're creating a special kind of material called a composite. This material combines different substances to produce something with superior properties. It's like mixing two ingredients, like flour and water, to make something even better: dough. By combining these elements, we can create materials that are stronger and more versatile. Our ingredients are a type of wax from plastic and fibers from plants. These components might seem ordinary, but together, they form the basis of our innovative composite. This mix might sound strange, but it creates a strong and eco-friendly material. It's a perfect example of how we can turn waste into something beneficial. Our process involves some cool science techniques. We use advanced methods to ensure the materials bond effectively and perform well. We use something called irradiation, which is like giving the plastic a boost of energy. This process enhances the properties of the plastic, making it more compatible with the plant fibers. This helps it combine better with the plant fibers. The result is a material that is not only strong, but also environmentally friendly. The end result? A brand new material that can be used in all sorts of ways, from building materials to packaging. This innovation has the potential to revolutionize how we think about waste and sustainability.
Our first step is preparing the main ingredient of our composite low-density polyethylene wax, or LDPE wax for short. This material is crucial for many applications due to its unique properties. You might recognize LDPE as the plastic used in things like grocery bags and some food wraps. It's a versatile material found in everyday items, making it an essential part of our daily lives. LDPE wax is just a thicker, more solid form of this plastic.
It retains the beneficial properties of LDPE, but in a more robust and durable form, suitable for various industrial uses. We start with tiny LDPE beads, which look like miniature white beads you might use for crafting. These beads are the raw form of our wax and are easy to handle and measure. To turn these beads into wax, we need to melt them down. This process requires precise temperature control to ensure the beads melt evenly without degrading the material. Imagine melting chocolate chips to make a smooth chocolate sauce. The process is quite similar, requiring careful attention to avoid burning or uneven melting. We do something similar with our LDPE beads. The beads are gradually heated in a controlled environment to ensure they melt uniformly. We carefully heat the beads until they melt into a clear, thick liquid. This molten state is crucial for the next steps in our process, as it allows us to mold the material into the desired shape. This melted LDPE is our wax. At this stage, it is a versatile material that can be shaped and solidified into various forms depending on the application. We can then pour this wax into molds and let it cool down and solidify. The cooling process is just as important as the melting, as it determines the final properties of the wax. Once cooled, we have our LDPE wax ready for the next exciting step in our process. This solidified wax can now be used in a variety of applications, showcasing the versatility and utility of LDPE in its wax form.
Now, here's where the science gets really interesting. We're going to use something called ionizing irradiation on our LDPE wax. Don't worry, it's safe and controlled. Think of it like giving our wax a little energy boost. We expose the LDPE wax to a special type of energy called gamma radiation. It's like giving the wax a quick burst of sunlight, but much more powerful. This radiation does something amazing. It changes the structure of the LDPE wax, making it easier to combine with other materials. This process is crucial for creating a strong bond between the wax and the plant fibers we'll add later. It's like giving the wax little hooks that the fibers can latch onto.
With our energized LDPE wax ready, it's time to add our second key ingredient, agro-waste fibers. Agro-waste refers to any leftover plant material from agriculture, such as stems, leaves, or husks. These fibers are strong and readily available, making them a perfect eco-friendly choice for our composite. Think of it like adding straw to mud bricks to make them stronger. The agro-waste fibers act as reinforcements, adding strength and toughness to our LDPE wax. We carefully blend specific amounts of LDPE wax and agro-waste fibers. The exact recipe depends on the desired properties of our final composite. We might want a more flexible material for packaging or a sturdier one for building. By adjusting the ratio of wax to fibers, we can fine-tune the properties of our composite. But why agro-waste fibers, you might ask? These fibers are not only abundant but also biodegradable, making them an excellent choice for sustainable development. They help reduce the reliance on synthetic fibers, which are often petroleum-based and harmful to the environment. By utilizing agro-waste, we're also helping to manage agricultural waste, which can otherwise contribute to pollution. The process of blending these fibers with LDPE wax involves precise measurements and careful mixing. Scientists and technicians work meticulously to ensure that the fibers are evenly distributed within the wax. This uniform distribution is crucial for achieving the desired strength and flexibility in the final product. The blending process can be adjusted to create composites with varying characteristics, tailored to specific applications. Whether it's for creating durable building materials or flexible packaging solutions, the combination of LDPE wax and agro-waste fibers offers a versatile and eco-friendly alternative to traditional materials. We can fine-tune the properties of our composite.
Now that we've created our LDPE wax and agro-waste fiber composite, it's time for the real test. We need to see if it lives up to our expectations. We perform several tests to check its strength, durability, and other important characteristics. One test measures flexural strength. Imagine bending a ruler. How much force can it take before it breaks? We do a similar test with our composite to see how much it can bend without snapping. We also check surface hardness. Imagine poking the composite with a fingernail. Does it dent easily or is it tough? This test tells us how resistant the composite is to scratches and dents.
We can't judge a book by its cover, and we can't fully understand our composite just by looking at it. We need to take a closer look, way closer. For this, we use a powerful microscope called a scanning electron microscope, or SEM for short. The CM allows us to see the structure of our composite in incredible detail, magnified thousands of times. It's like zooming in on a world map and seeing individual houses and streets. This close-up view helps us understand how well the LDPE wax and agro-waste fibers are combined. We can see if they're evenly distributed and how tightly they're bound together. This information helps us improve our composite recipe for even better performance.
Remember how we used gamma radiation to energize our LDPE wax? While this process is safe and controlled, we want to make absolutely sure that our final composite is free of any residual radiation. We don't want our new material to be radioactive. To check for this, we use a special device called a gamma-ray spectrometer. This device is very sensitive and can detect even the tiniest amounts of radiation. We carefully scan our composite samples with the spectrometer. The good news is, our process ensures that the composite is completely radiation-free and safe for use in any application. Safety is always our top priority.
So, what have we discovered through our experiments? By combining LDPE wax with agro-waste fibers using our irradiation process, we've created a new composite material with some impressive properties. Our tests show that the composite is stronger and more durable than LDPE wax alone. The agro-waste fibers act like tiny reinforcing rods, making the material much tougher and more resistant to damage. But it's not just about strength. Our composite is also better for the environment. By using agro-waste, we're giving a second life to materials that would otherwise be discarded. This reduces waste and promotes sustainability.
The possibilities for our new composite material are endless. Its unique combination of strength, durability, and eco-friendliness makes it suitable for a wide range of applications. Imagine using our composite to create lightweight yet strong building materials, reducing the need for traditional concrete or wood. It could also be used in packaging, replacing styrofoam and other non-biodegradable materials. The automotive industry could also benefit from our composite. Its lightweight nature could be used to create car parts, improving fuel efficiency and reducing emissions. The future is bright for our super composite. Science is all about exploring, experimenting, and discovering new things. If you found this research exciting, you too can be a material scientist. Start by looking around your own home. What materials do you see? How are they made? And what are their properties? Can you think of ways to combine different materials to create something new and improve? There's a whole world of materials waiting to be discovered. And who knows, maybe you'll be the one to invent the next super material. Before we go, let's take a moment to appreciate the wonders of science. It allows us to understand the world around us, from the tiniest atoms to the vastness of space. Science empowers us to create, innovate, and make the world a better place. Remember to stay curious, ask questions, and never stop exploring.
We stand on the precipice of a new era in material science. An era where sustainability is not just a buzzword, but a core principle. One key to unlocking this future lies in harnessing the potential of agro-waste, the often discarded byproducts of agriculture. Imagine a world where rice husks, sugarcane, bagasse, and coconut fibers become building blocks for homes, furniture, and more. This is the promise of agro-waste composites. These eco-friendly materials offer a viable alternative to the traditional petroleum-based plastics. However, creating strong and durable agro-waste composites presents unique challenges. Enter ionizing irradiation, a powerful tool capable of modifying the properties of materials at a molecular level. This process, coupled with the use of low-density polyethylene wax, is paving the way for a new generation of sustainable materials. This essay delves into the fascinating world of ionizing irradiation and its role in creating LDPE wax-enhanced agro-waste composites. We will explore the properties of LDPE wax, the challenges of incorporating it into composites, and the remarkable benefits it brings. Join me as we unlock the secrets of these innovative materials and discover their potential to revolutionize various industries. Low-density polyethylene wax, or LDPE wax, might not sound like a revolutionary material, but in the world of composites it plays a crucial role. Think of it as a binding agent, a lubricant, and a reinforcing agent all rolled into one. LDPE wax is a low molecular weight version of polyethylene, a ubiquitous plastic found in everything from grocery bags to toys. Its unique properties stem from its chemical structure, long chains of repeating ethylene units. These chains can slide past each other easily, giving LDPE wax its characteristic low melting point and flexibility. In the context of agro-waste composites, this translates to improved processability, enhanced mechanical strength, and increased resistance to moisture and decay. However, incorporating LDPE wax into agro-waste composites is not without its hurdles. One of the primary challenges lies in its viscosity, or resistance to flow. This can make it difficult to evenly distribute the wax throughout the composite material, potentially leading to weak points and inconsistencies. Imagine trying to mix honey into a bowl of oatmeal. You quickly realize that the thick, viscous honey doesn't easily blend with the dry oats. A similar challenge arises when incorporating LDPE wax into agro-waste fibers. The high viscosity of LDPE wax at room temperature makes it challenging to achieve a uniform dispersion within the composite matrix. This uneven distribution can lead to several issues. First, it can compromise the mechanical properties of the composite. Clusters of LDPE wax can create weak points, reducing the material's overall strength and durability. Second, poor dispersion can hinder the wax's ability to effectively coat and protect the agro-waste fibers, making them susceptible to moisture damage and degradation. To overcome this viscosity challenge, researchers have turned to ionizing irradiation. This process uses high-energy radiation to break down some of the long molecular chains in LDPE wax, lowering its viscosity and making it easier to incorporate into the composite mixture. Traditional methods of processing polymers often involve high temperatures, which can be detrimental to the integrity of agro-waste fibers. These natural fibers are susceptible to thermal degradation at elevated temperatures, leading to a decline in their mechanical properties and ultimately weakening the composite. This is where the advantage of using LDPE wax, particularly when processed with ionizing irradiation, becomes evident. Ionizing irradiation allows for the modification of LDPE wax at lower temperatures compared to conventional thermal processing methods. This lower processing temperature becomes crucial when working with agro-waste fibers, as it prevents their degradation and preserves their inherent strength and structural integrity. This ability to process at lower temperatures not only safeguards the valuable properties of agro-waste fibers, but also contributes to energy savings during the manufacturing process, aligning with the principles of sustainability that drive this research. The proof, as they say, is in the pudding, or in this case, the data. Table 1 showcases the remarkable impact of LDPE wax on the mechanical properties of agro-waste composites. The table likely presents data on tensile strength, flexural strength, and impact resistance, comparing composites with varying concentrations of LDPE wax. A closer look at the numbers reveals a clear trend. As the concentration of LDPE wax increases, so too does the strength and durability of the composite material. For instance, the tensile strength, which measures the material's resistance to breaking under tension, might show a significant increase with the addition of LDPE wax. Similarly, flexural strength, a measure of the material's ability to resist bending, could also see substantial improvement. These findings underscore the vital role of LDPE wax in enhancing the mechanical properties of agro-waste composites. The wax acts as a reinforcing agent, binding the agro-waste fibers together and increasing their resistance to external forces. This translates into stronger, more durable and longer-lasting materials. The potential applications for LDPE wax-enhanced agro-waste composites are as vast as they are exciting. Imagine a future where we replace conventional construction materials like concrete and plywood with eco-friendly alternatives derived from rice husks and coconut fibers. These sustainable composites could be used to create wall panels, roofing sheets, and even furniture, reducing our reliance on resource-intensive materials. Beyond construction, these composites hold promise in various industries. Their lightweight nature and durability make them ideal for manufacturing automotive parts, such as interior panels and dashboards. The automotive industry is constantly seeking ways to reduce vehicle weight, to improve fuel efficiency, and agro-waste composites offer a promising solution. Furthermore, these composites can be molded into intricate shapes, opening up possibilities in the furniture industry. Imagine chairs, tables, and even decorative items made from these sustainable materials, adding a touch of natural elegance to our living spaces. Hello again, and thank you for watching this comprehensive exploration of the groundbreaking research titled The Use of Ionizing Irradiation to Prepare Polyethylene Wax and Agro-Waste Composite. I hope you found it as fascinating and insightful as I did. This remarkable research was made possible by the collaborative efforts of an exceptional team of scientists whose dedication and hard work have been truly inspiring. I want to extend my heartfelt gratitude to Professor Dr. Hussein Elnahas and Professor Dr. Mohamed Elhady from the Polymer Chemistry Department at the National Center for Radiation Research and Technology, Egyptian Atomic Energy Authority in Cairo, Egypt. Their guidance and expertise have been instrumental in shaping the direction and success of this project. Special thanks also go to Professor Dr. Christopher Liauw from the Center for Material Science Research, Faculty of Science and Engineering at Manchester Metropolitan University, UK, for his invaluable contributions. His insights and support have greatly enriched our research and provided us with new perspectives. And my sincere appreciation to Professor Dr. Shabaan Kamel from the School of Science and the Environment, Chemistry and Environmental Division at Manchester Oxford Road, UK, for his significant role in this research. His commitment and enthusiasm have been a driving force behind our achievements, and his collaboration has been deeply valued. Their dedication and hard work have led to the development of innovative and sustainable materials, showcasing the potential of scientific research to address global challenges. Through countless hours of meticulous research and experimentation, these scientists are paving the way for a more sustainable future. This paper is a testament to their expertise and commitment to advancing science. It highlights the collaborative efforts and the rigorous methodologies employed to achieve groundbreaking results. The study has demonstrated how recycling agricultural and plastic waste can produce high-quality plastic wood with benefits such as water resistance and fire resistance. This not only helps in reducing waste, but also in creating materials that are both durable and environmentally friendly. This innovative material offers new possibilities for sustainable solutions. It opens up new avenues for industries looking to adopt greener practices and reduce their environmental footprint. Thank you, Professors Hussein Elnahas, Mohamed Elhady, Christopher Liauw, and Shabaan Kamel, for your extraordinary contributions. Your work is truly inspiring and paves the way for future innovations. If you enjoyed this video and want to stay updated with more groundbreaking scientific research and fascinating discoveries from the world of science, please like, share, and subscribe to the For Science Salah Lotfy channel. Your support helps us bring more insightful content to you. Let's continue exploring and celebrating the wonders of science together. Stay curious, stay informed, and thank you for watching.